Hello students, welcome to the second part on the lecture series of decimals and fractions. Okay, so before going into the content of this second lecture, let's review some topics that we have studied earlier. Okay, so we have previously learned the types of fractions. Okay, proper fraction, improper fraction, and the difference between these two, mixed numbers, equivalent fractions, unlike fractions, difference between these two. Okay, and proper equivalent fractions and improper equivalent fractions, and the difference between these two. Okay, we have learned all these earlier in the first lecture. Okay, so what we also learned was the types of decimals. Okay, so there are two types of decimals, that are terminating decimals, non-terminating decimals. So terminating decimals were the decimal numbers on which after the decimal point we have finite number of digits. Okay, 2, 3, 9, and it is finite, it ended right here. Okay, and what are non-terminating decimals? These are like 0 0.2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 7, 5, 6, and so on. These are non-terminating, that is after the decimal point. What we have is we have non-terminating digits after that. That is the number of digits after the decimal point are infinite, not finite. Okay, so this is also further divided into two categories, that is non-terminating repeating decimals. Okay, so in repeating decimals what we have is 0 point, we have a pattern after the decimal point. Okay, after the decimal point what we have is we have a pattern there, like 6 3 9 4 8, 6 3 9 4 8, and so on. That is, here you can see that the 6 3 9 4 8 up to this pattern is being repeated down here. Okay, so what we can write it as is 0.63948 bar. We put a bar above the pattern, okay, that repeats itself. Okay, in this case it is 63948. So if we write 0.2 bar, this will be equal to 0.222 and so on. So 2 is the repeating pattern here, only one digit that is being repeated further down there. Okay, so what are non-terminating, non-repeating decimals? These kind of decimals are actually also called as irrational numbers. We have already learned that pi, that is actually equivalent to 3.41679 8 or something close to this, and this is non-terminating actually, and e, that is equivalent to 2.714 and so on, that is non-terminating here. Okay, so these two are irrational numbers, and these are actually non-terminating, non-repeating decimals. That is, we can't find out a pattern down here. Okay, if we could found a pattern, then we can put it in non-terminating repeating decimals. Okay, this is non-repeating decimals, non-terminating and non-repeating. Okay, so let's jump into the contents of this lecture. Okay, so what we'll learn in this lecture is the types of problems. There are 10 types of problems that are being asked in the competitive exams on the topic decimals and fractions. So we'll explore each one, okay, in detail. So let's get a review around what we have here. So the first kind is converting fractions into decimals and converting decimals into fractions. Okay, and the seconds are on basic arithmetic operations, and there are some questions on simplification of fractions. Okay, and there are comparing decimals and fractions. It will be like something, you have 0.9 down here and a decimal like 3/7 down here, and it will say that compare these two. Okay, so these two are numbers, so one of these three scenarios are possible, that is equal, greater than, or less than. Okay, so which one is correct? Which one is correct? Okay, this may be asked. So these kind of questions are called comparing decimals and fractions. Okay, so there are percentage problems. Okay, we'll see it. And then we have word problems, operations with mixed numbers. Okay, we have previously learned that what are mixed numbers. If we have a whole number part in the fraction number, then we will say that the number is mixed number, like 1, 3 by 4. What it is equivalent to is, this is 4 into 1, 4 into 1 plus 3 by 4. That is equal to 4 plus 3 by 4. That is equal to 7 by 4. Okay. This. So, and we have ratio and proportion problems. Okay. And we have percentage increase and decrease problems. And we have also time, speed and distance problems down here. Okay. So, let's explore each kind in detail. So the first kind says that converting fractions into decimals and vice versa. Okay, fractions to decimals and decimals to fractions. So let's see how to convert fractions to decimals and decimals to fractions. So convert fraction to decimal. So we have 3 by 4, right? So we have 4 and we have 3 here. So 3.0. So 4 into 7, 28. So 0, 28 minus. So we can treat it as 30. So 2 here. Okay, we can put another 0 after this and get it down here. So what we will do is we'll do 4 into 5. Okay, so 4 into 5 means 20 and this is 0. So the remainder becomes 0. So we have got a proper decimal number, that is a terminating decimal number. Okay, that is 0.75. So this is equal to 0.75. So let's see the answer. Yeah, you got 0.75 as the answer. What we did was divide 3 by 4. We divided it here and you can see it. So this is the answer. Okay. If it would have been asked to convert 0.75, let's say convert 0.75 to fraction. How can we do it? Okay, let's see. So if we have given 0.75, so 0.75, this is equal to 75 by 100. We can write this. So by doing prime factorization, what we can see is 5 into 5 into 3 and 2 into 5 into 2 into 5. So this is equal to 25 into 3 by 10 into 10. That is equal to 75 by 100. Okay. So what we have is 75 by 100. Okay. So we can also cancel it here and get 3 by 4. Okay. So 3 by 4 is the what? Fraction born of 0.75. Okay. And this is nothing but 0.75. Okay. So the second kind tells us that basic arithmetic operations. Okay, so addition, subtraction, multiplication and divisions. Okay, involving the decimals or fractions. Okay, this kind of questions. Let's explore a problem on this. So here we are asked to evaluate 2.5 plus 0.75. Okay, in order to do this, let's convert this to fraction. Okay, so in fraction, what it will tell is 25 by 10. Converting this to fraction, what it will give us is 75 by 100. Okay, so let's add 25 by 10 with 75 by 100. So we know that here we have two different denominators, right? 10 and 100. So let's find the LCM. Let's find the multiples first. So 10, 20, 30 and so on. And then we have 100, 200, so on. And in this series, at some point, we'll get 100. Okay. Up before this 90, 80, 70, 60, 50, 40. Okay. And then 1, 1, 0. And this is something like that. And finding the commons, we can find out that 100 is also common in both the multiple series. Okay. And the lowest common multiple is nothing but 100. So the LCM of 10 and 100 is 100. So let's convert 25 by 10 fraction into a fraction which have denominator as 100. So 100 down here, that means 10 into 10. So we need to multiply the numerator with 10. So 25 into 10. So plus 75 by 100. So this is equal to 100, and in the above it is 250 plus 75, that is equal to 325 by 100. Okay, so this is the answer, that is nothing but 3.25. Okay, so this is the answer. So here we can also solve it by adding the decimals directly. Okay, so adding the decimals, how it works is method 1, and here the method 2. Okay, so 2.50 we can write. Okay, 0.75. so adding these two, so here we can get 5, and 7 plus 5 is equal to 12. So we have got 2 down here, and we get an addition here. So 2 plus 1 is equal to 3, plus 0 is equal to 3. So 3.25 answer. Okay, so 3.25 here, 3.25 here, these two are same because the methods are different, but process is correct. Okay, so let's jump into the third kind. Okay, the third kind is simplification of fractions. So simplifying complex fractions into their simplest form. So let's figure out a problem on this. Okay. So it asks us to simplify the fraction 6 by 12. So what we need to do is we find there are two methods. Okay, method 1, prime factorization, and method 2 is GCD. Okay, so let's do it by prime factorization first. So 6 by 12. Okay, here you can see that the numerator is 6 and the denominator is 12. So let's do their prime factorization. So this is nothing but 2 into 3, and this is nothing but 2 into 2 into 3. So we can cancel 1 2 and 1 3 here, and what we get is 1 by 2. Okay, this is the simplest form. And let's see the method of GCD. So let's find out the GCD of 6 and 12, right? So how can we find it? So what is GCD? This is divisor, common, greatest. Okay, so in order to find the greatest common divisor, what we need to see is we need to see the divisors of 6 and 12 individually. Okay, so for 6, divisors of 6 are equal to 1 2 3 6. Okay, and divisors of 12 is nothing, 1 2 is equal to 1 2 3 4 6 and 12 itself. Okay, so we need to find the common ones. 1 1. Okay, and 2 2. Okay, 3 3. Okay, and then what we have is 6 and 6. So this is the greatest. So GCD of 6 12 is equal to 6. Okay, so what we need to do is we need to divide the numerator by 6, that is 6 by 6, and divide the denominator by 6. So that is 12 by 6, that is equal to 1, and that is equal to 2. So this is nothing but 0.5. Okay, this is also equal to 0.5, that are same answer. Okay, so comparing decimals and fractions is the four kind of problem, okay, that is being asked normally. So let's see the problem on this, that is compare the decimal 0.6 and 0.65. Okay, So what we can see here is 0.6 is nothing but 0.60, right? And 0.65 is nothing but 0.65. So in the 100th place, you can see after the decimal in the 100th place, see here, we have 5 down here and we have 0 down here. So since 0 is less than 5, okay, so we can conclude by this, since the 10th place are same, we need to compare the 100th place, and we compared it and we found out that the second one is bigger than the first one. So 0.60 is less than 0.65. Okay, this is the answer. Okay, this, yeah, 0 hundredth and 5 hundredths. Okay, and 5 is greater than 0, that is why this is greater than. So this is the answer. So let's see the fifth kind of percentage problems. Okay, so the fifth kind is percentage problems. So calculating percentage involving the decimals and fractions. Okay, so what is 25% of 80? Okay, let's see how we can find the 25% of 80. Okay, so what we need to do is first convert this percentage, that is 25 percentage, into decimal. So percentage means 1 by 100, right? So 25% means 25 by 100. This is equal to 0.25. And after this, what we will do is we need to find 25% of 80. Okay, so we will multiply 0.25 into 80. Okay, so what it will give us is 25 by 100 into 80. This is equal to 25 into 8 by 10. So this is equal to 200 by 10, that is equal to 20. So 20 is the final answer. Okay, so answer is 20. Okay, let's see. So to find a percentage of a number, multiply the number by the percentage. Okay, so convert the 25% to a decimal, that's 25% is equal to 0.25, and then multiply it by 80. Okay, so what we got was 20. So we got the correct answer. Okay, so the sixth kind of problem is word problems. Okay, so let's see an example on this. So a recipe calls for 3 by 4 cup of sugar. If you want to make a half of the recipe, how much sugar do you need? So half the recipe, half, what it means is 50%, right? Half means implies 50%, and what 50% is equal to 0.50. So half HA of 3 by 4 is nothing but 50% of 3 by 4. So this is equal to 0.50 multiplied by 3 by 4, that is equal to 50 by 100 into 3 by 4. Okay, so this is nothing but 25 into 3 by 1000, no, by 200. Okay, so this is equal to 75 by 200, that is equal to 3 by 8. Okay, so 3 by 8 is the answer. So let's see what is the answer. So find the half of this, that is 1 by 2 into this. Okay, we have got 3 by 8 here. Okay, this is the answer, and what we have is 3 by 8. Okay, same answer. So let's see the seventh kind of problem, that is operations with mixed numbers. So here what we'll deal with is, we'll deal with the addition, subtraction, multiplication and division involving mixed numbers. So let me remind you what were mixed numbers was. If we have a fraction, okay, let's say 3 by 5, but it has also a whole number part. This part is whole number part. Okay, if this is non-zero, that is we have something in the whole number part that is not equal to 0. Here 7 is not equal to 0. So these numbers are called mixed numbers. Okay. So let's get an example on this. So how to convert the mixed number into a fraction? Okay. So if we are given x and the whole number part and y by z in the fraction part, okay, numerator as y, denominator as z. So how we'll convert this is what we do is we multiply z into x, then add with y, and we keep the denominator, that is z. Okay, so if we are given 2 into 2 3 by 4, okay, so this is equal to 4 into 2 plus 3 by 4, that is equal to 8 plus 3 is equal to 11 by 4. Okay, this will be called as the fractional form of this mixed number. Okay, these two are same. So now let's convert these two individually and then subtract. Okay, so for 2 3 by 4 we have already known its fractional form. Okay, let's see the fractional form of this. So for 1 by 3, what we have is 3 into 1 plus 1 by 3. So this is equal to 3 plus 1 by 3 is equal to 4 by 3. So what we need here is 11 by 4 minus 4 by 3. So what we need to do is we need to find the LCM of 4 3. So how we can find it? We can find it by getting the multiples first. So 4 8 12 16 etc. or so on, and then we have 3 6 9 12 and so on. Okay, so the lowest common multiple, so this is the common here. Okay, nothing lower than this, so this is the lowest common multiple. So the answer is 12 here for the LCM of 4 and 3. So we need to convert these fractions into fractions with denominator as 12. So 12 33, because we multiplied with 3 in the denominator and in the numerator. Okay, and then in order to make this 12, so what we need to do is multiply by 4 in the denominator and the numerator. So 3 into 4 and 4 into 4, so that is equal to 33 by 12 minus 16 by 12. So this is equal to nothing but 16 17 by 12. Okay, so this is the answer. And what we can find out here is 1 power 5 by 12. Okay, in the mixed number form, this will be the answer. Let's see. So what we did is we first converted it. Okay, and then this is the answer that we got. Okay, same answer, 17 by 12, and here 17 by 12 can be also written as 1 5 by 12. Okay, here in the mixed number form we got it. Okay, so the 8th kind of problem involves ratio and proportions. Okay, so the problem is related to ratio and proportion. So if we see the problem here, if the ratio of boys to girls in the class is 3:5 and there are 40 students in total. Okay, total students, and boys is to girls is equal to 3 5. Okay, this is what given. So it tells us that how many boys are there. So what you can see here is boys is to girls, so boys by is equal to 3 by 5. So the total number of parts here is actually total parts is equal to 3 plus 5. Okay, these are equally proportionate parts, so this is equal to 8. So 8 equally proportionate parts is equal to 8 parts is equal to 40. So this implies that 1 part is equal to 5. So this implies that 3 part is equal to 15 and 5 part is equal to 25. So the number of boys is equal to 15 and the number of girls is equal to 25. These are the answers. So 15 will be the answer, as we are asked how many boys are there. Okay, boys have 3 parts, so that is why 3 into 5 is equal to 15. Let's see the answer. Add the parts of the ratio to find the total parts. So we first added them and got 8. So divide the total number of students by the total parts. So what we got was 15. Okay, so there are 15 boys in the class. And so the ninth kind of problem is on percentage increase or decrease. Okay, let's see an example and we'll get a grab on it. Okay, so if the price of an item increases by 20%, okay, you have a biscuit down here, okay, and its price jumps by 20%. Okay, so what will be the new price? Okay, so how to find it? First, what we need to do is we need to convert the percentage increase to a decimal, that is 0.20. Okay, so calculate the increase. So increase is equal to 0.20 into original price. That's how we can find out the new increased price. Okay, so calculating the new price is equal to new price plus original price plus increase. Okay, what we got was, if x is the was the price of biscuit before increase, okay, and what was the increase was by 20%, so 0.2 into x, that is equal to 0.2x, and now the final price, final or present price is equal to original price, that is x, plus the increased price, that is 0.2x. This is equal to nothing but 1.2x. Okay, this is the answer. So the new price will be the original price plus 20% of the original price. So the 10th kind of problem will be on time, speed and distance problem. Okay, using decimal and fractions to solve the problems related to time, speed and distance. So a car travels at a speed of 60 km per hour. Okay, you have a car down there and it travels at a whooping speed of 60 km per hour. Okay, so how long will it take to cover a distance of 180 km? Okay, so you have a car that travels at 60 km per hour and you need to find out how much time will it take to cover 180 km. Okay, so first what we need to do is find the time taken using the formula time is equal to distance by speed. We already know this in 8th class. Okay, so then substitute the given values. So after doing that, what we got was 180 by 60 is equal to 3. So that is why we will need 3 hours to complete the journey. Okay, so it will take 3 hours to cover a distance of 180 km at a speed of 60 km per hour. Okay, so this is the answer and this is all for now. Thank you.